So hello and welcome to this video where we are gonna look at LUnit. So the purpose of this video is really to introduce LUnit, give a quick demonstration of what it looks like and walk through the different features of the toolkit. So LUnit is a unit testing framework for LabVIEW and it's freely available. It's completely open source and you can get it through VIPM. Source code is available on GitHub. Please feel free to do what you want with it and contribute to the project if you have ideas for improvements or if you find issues with it. So yeah, without further ado, let's just jump straight into it. So yeah, LUnit follows the same kind of pattern as JKI tester does. So it's the XUnit familiar industry standard kind of way of writing unit testing frameworks. And one implication of this is that we group our tests into a class containing them. So we have something called a test case class. And within this class, we will then create our test case methods, which are the actual tests. So let's just begin by creating a test case class from this button here in the toolbar. So these buttons are added to the toolbar after you have installed LUnit and restarted LabVIEW. So once done, we can use that to create a test case. So yeah, let's just use the default name for now. I'm happy with that. And what it does, it spits out a new class for you here in the project. So now we have a test case class, which we can use to start hanging test methods onto it. So the easiest way to get started is just to use this template. Right click it and select new from template, and there we go. We have a test method, and looking at this, we have a front panel, and the important thing here to notice is that it needs to have the test case going in and out of it on the top here, as with a typical static dispatch VI. We also need to have the error output here on the lower right. You can have an error input if you like to. It doesn't make any difference, since you will never have any upstream error coming into the test method from the framework when the test methods are executed. One thing to mention here is maybe that the test names need to begin with the four letters TEST. So the case doesn't make any difference. You can use upper or lower case, but it needs to begin with these four letters in order for the framework to recognize that this is a test case which should be executed. So yeah, let's look at the block diagram here. We have something called an assertion here on the top right. So this is just the method that we use to verify what the test is about to test. So in this case, we compare two strings, and comparisons are then of these two values. And as you might expect, this test would now fail because comparing a placeholder to an empty string doesn't give anything. So if you want to run this test, which we maybe should do next, let's just then first save this. It needs to be saved in order for the test enumeration to find it. The test demo. Now we have saved it, and then we can just run the VI here, and this will then kick up the user interface and report the results in there. And as you see, it failed. And we can even click on the test here and the result here to get some more details. And here it then explains that this expected placeholder of type string, but it got nothing of type string. And this type specifier is quite useful because this is actually a mailable VI, so it can take any kind of input type. So let's replace that with a numeric, for example, and run it again, and then you see that now we get this string compared to a numeric. And important here is that both the type and the value needs to match. So if I change one to a U32 and one to an I32, it still fails because they are different type, even though they are both 0. And we can change it back to I32 and then the test passes. So yeah, we have a few different assertions to choose from here. They are found in the LUnit palette down here, and we can just pin it for now. So we already looked at passive equal, which is the one I use the most at least. We have this one which passes if there's an error coming in. We have this one which passes if this boolean is true. And then we have these which are negations of the above assertions. So basically this will fail whenever this passes and vice versa. We also have this skip method. So yeah, it can be used to ignore tests, which might be kind of a red flag. So I don't really use that much, but yeah, anyway, you know that it's there. So in order to add an assertion to the test case, we always need to draw this wire, this class wire needs to go through the assertion. And this is because the test results are collected by value. So they need to be appended to this test case class when it executes. Good. Did we have anything else to say about that? If we have some advanced assertions, we can check for specific errors within an array of error codes to be more selective. And then we can use this one, which compares if a element is a member of a collection. So it will pass then if the element is found within the collection. And this one actually works with any type. So it can be a string, a numeric, a cluster, whatever. And the collection can then be a set or a map, but it could also be just an array, and it will work with that as well. So yeah, some of those maybe more rarely used assertions are available from this advanced assertions palette. Yeah, there's an API for calling tests programmatically as well, but let's have a look at running test cases, and let's maybe close this project for now and look at this example. So here we have actually 4 different test case classes. And if I then select run all here from the toolbar, this will go ahead and run all the tests within the project. And you see that now all these classes, they get this kind of overlay here. So the red one means that the test case was failing, meaning that at least one of the methods in the test case here failed. And similar for this only has one method here, but this one failed, so the whole test case fails. And then we have a passing test case, which then passes, so it gets a green overlay. Yeah. Yeah, you can run tests. You can run all the tests in a project from here, but you can also run the tests in a specific test case class by right-clicking it and selecting run test case. So this will just run that test case here. As we saw earlier, we can just open the test case method and run that one, and this will show the results here in the UI. I don't know if you have time to see it, but let's just close it. Then it pops up and shows the result here. We also have, let's maybe add some more here, run another test case and we get some more results. So we have these buttons here on the top. This is the run button. So by default, this will run all the failing tests or all the tests that have never run before in the project, or not in the project, but what we have here in the UI. So if I press this, you might be able to see that this doesn't really run because this and this already passed. So we save some execution time and we only run the failing tests. If all the tests have passed, then this will run all the tests again. And if you shift click this, it will do the same. We also have this run once or run selected tests button, which we can then use to run a specific test or a specific test case class, like so. So just selecting from the list, you can also select like this and then run those if you want to. We can refresh the list and we have a button for aborting executing tests. Yeah, I'm not quick enough to click it now, but you get the idea. We can collapse and expand the list of tests. And we can use this one to eject the result view. So this just ejects the data from here. And the purpose for this view is really to keep the results around while closing this UI. As you see that this UI actually locks the test case classes, so we can't add or rename methods to them. We can't also edit dynamic dispatch VIs called from these VIs. So in order to release those, we need to close down the user interface, but we can still keep the results in this result view. And we can still use them to double click on the test methods to open up the VIs. Good. let's have a final look at some other features. Maybe let's have a look at this test coverage ID. So here we have a test case where we have this VI under test. It's here in the project, and it's pretty simple. We just have a case structure with two cases, true case and a false case. And now we have two tests for it. So we feed a true and a false boolean into it, and it will then run one or the other test, the other cases here. So if we wanted to measure the test coverage for a VI, we can enable it from this tools menu, select coverage analyzer, and then we run the test. And it pops up this this result view here that shows that we have 100% coverage for this VI under test. There are some limitations to this, and it's not maybe completely ironed out yet, but if people find this useful, we could probably improve it some still. But the basic functionality is there. So if we, for example, then change this to true, then the false case will never run here. And if we now run this test case and we enable coverage analysis, you see that we only get 75%, and that's how LabVIEW counts how much percentage of the block diagram was traversed during the test. We also have this execution profiler. Let's maybe add this one to the test to here as well, and you see that this actually shows a histogram of all the tests run, and this can be useful if you have a big test suite which you want to optimize test time for. Then typically there's only a small part of the tests which actually take a lot of time. So this can be used then to figure out which tests are the slow ones, which you should invest time in improving. And yeah, both of the tools are activated from this menu. We have this reporting, but to be honest, I think these text reports are mainly used for CI type of workflows, so nothing that I would use from the development environment, because yeah, I prefer this UI instead of a text file. And yeah, what else? We can maybe show this. Yeah, we have some options in the file menu as well. We have run tests in parallel, so by default this is actually enabled, and the tests are run in parallel by the framework. And this then runs each test case in a parallel test runner. We also have this ability to ignore dashed tests. So let's see what that does. So maybe we should close down those and create. So a dashed test, this means that we add a dash to the beginning of the test name, like so. And this is something that I typically use if I have some test which takes a lot of time to run, but I still want to keep it around because it tests something useful. But I don't want to run it every time I run the full test suite. So then I can select to ignore dashed tests, and then it should ignore it when I run it here, which it didn't. Strange. Oh, okay, that was because I run this specific test case. If I do it that way, it will actually run everything. But when I run all the tests in the project, it actually skips this test which has been dashed. I can still run it by selecting it, or the equivalent to what I did a moment ago was to run the whole test case, and then it actually runs as well. So yeah, this is kind of a way to selectively run tests. So I can disable this again, and then it will run always, like so. But yeah, maybe those were all the features that I wanted to show you. There isn't really that much to it. So basically, yeah, you use the user interface to execute the tests that you write, and the key features here are really the integration with the project, right-click menus, the overlays, and then the speed of the framework, the execution speed, and the loading time of the user interface. Been putting a lot of effort into making that as quick and as close to instant as possible, because when you work in a typical TDD workflow, you tend to run tests quite often, and you close down the UI, open it up, and you want this to be very quick so that you don't need to wait too much. And yeah, thanks for watching, and I hope you found this video useful.